Good morning, and welcome to the O-Scope Wizard. I just noticed my timer ran out, and I was just happily typing away in the chat, and I didn't start the show. But thanks for joining. Thanks for joining in the chat early. I appreciate that. Happy Baby Friday. I am Gabe, the O-Scope Wizard. You have made it to the O-Scope Wizard show, where we will nerd out for about 20 minutes. And on that note, let's get the timer started. Let's see, 20 minutes. Before we get too far down the road, 20 minutes set up on the timer. Good and plenty's at hand. It's a Baby Friday, so it's gonna be a good day, no matter what. Let's do a quick show setup. We have been attempting to build an IRL in real life subtitle necklace. Subtitles make me hear better. I thought that subtitles would make everyone hear better. So that is what we are attempting to do. We're going to make it out, hopefully, out of a Raspberry Pi, some microphones, we got some LEDs. It's a whole contraption. And on the last episode, we were working diligently to try to solve some power supply issues on the Raspberry Pi, and I got quite a bit of help from the crew here, and I appreciate it. So, with that set up, let's get into it. Probably not a blank screen. Today for power supply help, I have this really fancy brand new NGP800 that has all kinds of power options. And in fact, it can go up to, what does it say? 32 volts and 20 amps on a couple of these guys, which will be way more amps than we need, because from our measurements, if you remember, I wrote them down so that we would not have to forget, and it would help us remember. From our measurements, my Pi was drawing about 220 milliamps. My LEDs, when they were all on, were drawing about 760 milliamps, and then my audio board, my little microphone board, drew about 30 milliamps for a total of about an amp, about 1 amp. Today, I wanted to try to, first of all, let's point the camera a little bit this direction so you can see me while I'm working. I have purchased, of course, I purchase something. I purchase something almost all the time, all these little doodads and whatnots. When I was a little kid, I think I've told this story before, but there was a box of cracker snacks. It's a box of cracker snacks, and it was called doodads. Doodads. That was the name of the snack. And it came in a box, kind of like Cheez-Its. And the box was sitting on the table upside down. And I kept asking my mom, who's in the chat now, can testify to this story. I kept asking her, pass me the spapoops, which is doodads upside down. You write it down on a piece of paper, turn it upside down, spapoops. Not that that's terribly useful, but that every time I hear the saying doodads, I always think, pass me the spapoops. Now you're in on the joke, and now we can all share it together. So, spapoops that I have purchased. Battery. I have this lithium-ion battery. Can we see? Can you find it? Can you find it? Let me turn off the light here to see if that'll help. Might not be able to find it. There it goes. There it goes. Bless its little heart. This is a 3.7 volt, 1600 milliamp hour battery. I'm mostly concerned with the milliamp hours. How many milliamp hours does this battery hold? This battery is 1600 milliamps divided by 1, because my contraption that I'm building, we think, is going to draw about 1 amp when it's running. So if you divide 1.6 divided by 1, even I can do that math. This battery should power my contraption for about 1.6 hours, I think. Another thing that is on the back of this battery First of all, it has 5-volt pins on the back, so it actually powers the Raspberry Pi through some test points on the back of the Raspberry Pi. We see, if I flip my Raspberry Pi over, there's all these test points for all kinds of different probing, which can be helpful if you're actually testing it. But you can also use it to power the Raspberry Pi. So this board cleverly sits on the back of the Raspberry Pi and powers the Raspberry Pi. It also has some I2C connectors so it can communicate with the Raspberry Pi and check battery. The Raspberry Pi, I think, can check battery levels and shut itself off when it gets to a certain battery level. But I want to see if I can get it connected. It should be pretty easy. And just require 4 screws with these little grommets that are going to hold it flush-ish. The downside of this is there are no headers to tell me that I'm plugging it in the correct direction. Also, I have these through holes which have proven to be a little bit difficult to make connection with this little these I2C pins on the back. I think we can make it all work. I have made it work. Every time I plug in power, though, I'm always nervous I'm going to plug it in upside down and end the life of my Raspberry Pi. Let's point this down a little bit more so you can see me struggle. I'm just trying to power this Raspberry Pi as we will in the end project. This battery can both power the Raspberry Pi and be charged at the same time, allegedly. We will test that. We will. Little fiddly bits. In the chat, my mom asked, did I put the net around the trampoline again? Because that was the video that was playing before the show. But no, the net is not around the trampoline still. That is just an old video. I just like that video because it's kind of also a fall video. It's from actually winter. So it has been a while. I need to make some more, you know, like hanging out videos. And we are lined up. One good thing about having the screw holes with the little grommets is it automatically lines everything up as long as you are plugged in the right way. See, there. As soon as the Raspberry Pi makes connection, it starts powering up. For better or worse. For better or worse. It might be for worse right now because I don't have the screw totally seated. We will get this happening. We will get this happen. I don't know if we'll use the I2C today. I am curious to see if we can at least talk to it. I mean, I bought this battery thinking that it will be a neat addition to the project since it does have that I2C link, so it has a little bit of smarts built into it. We can follow a web page, supposedly, and get some of the code for it. Again, that Raspberry Pi community making it easy to develop since somebody else has probably done most of the developing for you. In fact, on the last episode I talked about an Element 14 project that essentially did the same thing, except they put their LEDs directly on their face mask, which was really neat. It was a lady named Lorraine who did a really good job. And ultimately, though, she had to abandon the Raspberry Pi for the real-time speech recognition. And I am really hoping to use the Raspberry Pi for the real-time speech recognition. So, Raspberry Pi is allegedly on right now. Can we? Let's see. I haven't tried to connect to it yet. With it being powered by the battery, it's kind of neat because the Raspberry Pi is just like chilling out there by itself. Let's see if we can actually connect it. My mom likes the blue light. I like the blue light as well. In fact, blue lights are, I think, might be my favorite LED color. I think that's. I mean, I don't have to think. I know. Blue lights were my favorite LED color before I made my amplifier and made pink lights. And now I think pink lights might be my favorite LED color, but nobody puts pink lights on stuff. That's a real oversight on designers' parts. We are in like Flynn. That was super duper easy, right? Goodness gracious. It works. I'm amazed. I am amazed. Curiosity, though, is forcing me to think about what the voltage level is on the Raspberry Pi pins. Last week, we struggled getting this thing powered because our voltage level was only 4.5 volts, and we ended up having to use a USB power brick to get the voltage level up. If you undervoltage these Raspberry Pis, they get super ill-tempered. I want to know, what is the voltage level from this battery? How close to 5 volts is it? Is it a 3.7 volt cell with presumably a boost converter to get it up to 5 volts? In fact, we can, you know what? I have a browser window showing the battery that I purchased. So I got this battery. This is the actual battery that I purchased off of eBay. And what does it tell me? It tells me, it tells me it can supply up to 2.4 amps, which would kill that battery real quick since it's only a 1.6 amp hour battery. Does it tell me on this listing? It doesn't tell me much. It has a really cool project example with a screen. I don't have a screen on my project, just LEDs. I haven't graduated to screens just yet. Let's follow the website, the web address, to see what we have to say about this battery. So this is the I2C communication for this battery, which eventually I'm hoping to download and use, but it does say in this PiBat, it's using the MCP3021 to make measurements, but I am not sure what an MCP3201 is. MCP3201, what is it? It looks like it might be an A to D. It is. It's a 12-bit A to D. So it's measuring the voltage with this A to D, which is, you know what? You know another way to measure voltage with an A to D? Huh? Huh? Hint, hint. Hint, hint. Anybody? How? Show title? Show title? Anybody? Oscilloscope? Oscilloscope? We're gonna measure the voltage with our own A to D, and it is built into this oscilloscope. So I have my voltage probe, my power rail probe. I will plug it in to the pins of the Raspberry Pi and make a measurement. I need to make sure that I plug it into the 5-volt rail. That means I need to make sure that I'm plugging it in the right direction. And that is, okay. So I have my my breakout board here connected that gives me double access to my GPIO header. I'm going to measure the 5-volt rail to see how close to 5 volts we are. Probably need to connect ground first. I always connect ground first. Give me a shared reference before we start plugging in voltage signals so that, you know, I don't accidentally whap something. Whap it. Potentially whap it anyway. Now, let's go back to the oscilloscope and see if we can figure this out. So, first things first is maybe I should find the oscilloscope on my computer. Let us preset it. Gotta preset it. I had this plugged in backwards. There is a chance I have this plugged in backwards. Certainly I do not have it plugged in backwards. I don't think this, This voltage rail probe is telling me different though, isn't it? Because it is at 0. Okay, quick test. Do I have this plugged in backwards? All right, what am I doing wrong? What am I doing incorrectly? Oh, this thing doesn't see my scope does it see the probe? I think it does. Okay, 5 volts. And ground. Allegedly. Is this right? Let me make sure. Yeah, I think that's hold on. Is my cable loose? Let's see. No. Why? Let's make sure we got the probe set up over here. So, probe setup. Probe meter. 1 millivolt. That doesn't seem possible. On account of me having a 5-volt rail here. What is going on? Where's my 5 volts? How close am I to 5 volts? Why is this not working? Why is this not working? On the last episode, there was a comment, a quote that says, when things get weird, measure the weirdness. We are officially pretty weird right here because I am measuring a 5-volt signal, but my oscilloscope is telling me it is 0 volts. If I plug on this pi hat, how angry does it get? Do any LEDs pop on if I plug this on? Probably not, but since it fits and lines up, it makes me think that I do have my adapter plugged in correctly. I was a little concerned that I might have this reversed. Certainly, though, those pins would not go back across the Raspberry Pi. Okay, let's try something a little bit more straightforward, a multimeter. When in doubt, simplify the task. So we were using an oscilloscope, which is a spectacularly complicated way to measure a DC voltage if you are not worried about the noise. Let's use a multimeter to see what the story really is. Simplify. All right, I've got my incredibly cheap multimeter today. I had to scooch my other multimeter out of the way because my power supply was so big, taking up all the desk space. All right, negative, positive. Does it not bring? Certainly the 5 volts comes out to the GPIO, right? None of the, excuse me. None of my GPIO is gonna show anything. 3.3 volts, nothing. 3.3 volts. What's this ground down here say? Nothing. What have I done to my Raspberry Pi, sir? What if I get this out of the way? Just go down here and take a look. So this should be 5 volts or thereabouts. And this should definitely be ground. Is my ground bad? Did I short a ground? Or have I lost a ground? I might have a bad solder connection. Let's go back to my, back to my ground. So this is what I was using the ground, which is the third pin down on the right side of the GPIO. And if I plug in my probe here, nothing. But if I keep my probe plugged in at that point, and then plug into this bottom ground, 4.8 volts, 4.9 volts. You know what? I have a continuity checker. Let's do a continuity check. So that is going to tell me whether or not that ground pin that is giving me trouble is shorted or not. So is it connected to ground? So here's one ground. Here's my other ground. I have, oh my, I think I see what's happened. I have lifted a pad off of this ground right here. Can you see that? Can you see that, kind of that blob of solder? At some point, I have torn that ground up so that it is no longer, no longer making connection.
5 minutes remaining!
5 minutes remaining. 5 minutes remaining. Ah! Oh, man. Okay. Oh, no. Oh, no. Oh, no. Oh, no. The chat was trying to help me out. The chat was trying to help me out, and I wasn't paying any attention. I apologize. I would apologize. The chat's like, stop, you're going to fry something. On a positive note, I did not fry anything. Oh my, oh my. I did not fry anything. That was a, you are watching, what would we call this? We would call this poor test engineering in action. I'm pretty cavalier with my $5 Raspberry Pis. Let us disconnect this battery and take a look at that ground pin on the back. That'll be the last thing we do today. This battery is supplying 4.9 volts, which is good. And I think it will turn off. I think it'll turn off. Turn off battery. Through a series of Morse code beeps. Don't you hate it when the interface is just one button? It's like the ultimate under-engineering. It's just one button that's going to do 18 different functions. And all I really needed to do is turn it off. Just turn it off. Turn it off. Turn it off. All right, we'll just disconnect it this way then. If you're not going to turn it off the right way, we'll turn it off this way. All right, battery's out, battery's out. Man, would that have not been epic if I had let the smoke out of the Raspberry Pi? A second Raspberry Pi? How many Raspberry Pis do I have to fry? I think the answer is all of them. I will not be happy until I have a stream of Raspberry Pis. Let's see. Oh no, oh no, the chat's saying I may have damaged something and I don't even know it yet. That's true. I know that I've damaged the GPIO header on my Raspberry Pi. At the very least, I have managed to pull up a pad somehow. Okay, that's it. That is it, right there. The solder has actually pulled off the pad. It looks like the pad might still be there. Let's see if I can get it on the big camera real quick. Big camera time. Big camera time. Right here. Let's see. Find it. There we go. Can you find it? Big camera time. Might be too close. Too close. Right there. Is that it? one of these pins right here has been, yep, that one right there, it's pulled up, and it is no longer making connections. So I need to do a little bit of soldering, so that my Raspberry Pi works again. That's a bummer. That is not the first. I can still see some copper around it. Oh, let's get me in focus again. I can still see some copper around it, but it has definitely come off. Oh man, the pin is totally loose. Oh yeah, look at that. I can stick it up. Here we go. This. You don't want your soldered pins to be able to pop up like that. That is no bueno, sir. I might need to get another Raspberry Pi Zero for the project, because I think, well, it looks like there's still copper down there. I just have a totally cold solder joint that didn't stick. I think. Oh, soldering, my Achilles heel. I am good at many things. You know, I can read pretty well. I enjoy listening to music. I'm very good at listening to music. Not good at soldering. I am trash at soldering. And I also I even ordered new solder tips for my soldering iron, and Amazon managed to lose them, as if Amazon also knew I was trash at soldering and just said, don't bother. Don't bother. Keep moving, Mr. O-Scope Wizard. Well, I will stop the timer because that's my 5 minutes. Have diagnosed why we weren't measuring voltage. It was because the pin that I chose to use as my ground reference had popped off the board, and I made a continuity test while the circuit was live, which is also a no-no, because I could have easily shorted more things together. But you know what? You live and you learn. This is what the show is about everybody learning how to do DIY electronics at your house together. And I don't know all the nerds in the world, but I'd love to meet them, so please share this with a nerd in your life, especially one who is, you know, trying to learn how to use a Raspberry Pi, or maybe a multimeter, or wants to see how not to do things. Watch this guy. And I will see you guys next week, probably, at the very least, with a resoldered ground pin, and maybe with a new Raspberry Pi. Maybe. Fingers crossed. Later, guys. Bye.